and I have the honor of introducing Will Hart and Margaret Upshur. Will Hart, who demoed our particle mesh hardware this morning, is the general manager of developer tools here at Particle. He's also one of the earliest Particle team members, and as such, has been deeply involved with the hardware manufacturing process that takes place in Shenzhen. Margaret Upshur is the director of operations at Particle. Those of us on the sales team know her as the foremost spreadsheet guru, but for the rest of us here, she's the one who's responsible for getting hardware into your hands. So whether you are developing a project at home or you are managing a scaled deployment of IoT products, her team has been instrumental in supporting you through that process. So please give them a warm welcome. They'll be discussing what it takes to get your product from prototype to production.
Thank you. So together, Will and I are responsible for prototype to production. So we're very excited to have this talk with you guys today because it is a often misunderstood and often full of trip-ups part of the product development process. So as we talk today, we're going to go over a couple things that are recurring themes in the prototype to production process. So the first one is the idea that when you design this entire system, you need to think about the what instead of the how first. So you need to think about what is the problem that I'm solving for customers. You heard that earlier in the keynote as well, but that should carry through into your entire supply chain design and prototype design. The second thing we'd like you to take away from this talk is that time, the cost, and complexity on this entire prototype to production process is often underestimated. And a lot of times it's easy to say, okay, I made a sample. This sample is great, it functions perfectly. And then you take it into the next step and whoops, it doesn't function perfectly when you have 50 units because you actually have a 10% defective rate or something like that. So that's the next thing. Don't underestimate this portion of the process. And the third thing we want to make sure you all take away from this is that the right partners are going to help you get through this process smoothly. So no, you don't have to do it alone. You can pick the partners at the right points for the portions of the supply chain and prototyping that you don't know how to do as well, or you haven't developed the capabilities for yet. Cool. So we're going to go through 10 steps here. Will is going to take us through the first 5, and I will take you through the next 5. It's a U shape, so you have to read right to left. It might be a little difficult. But we're going to start off here with the business model, a critical thing to get right. And so Will's going to take us through that first.
Great. So talking about the business model, right? This comes back to the conversation that we had earlier, as Margaret mentioned, about starting with the problem you're going to solve. So once you've identified a problem you're going to solve, I think the next piece of it is to figure out, okay, how can I build a business around the solution to this problem? And I think one of the things that's different about IoT from traditional hardware sales is that IoT products have a recurring cost structure, right? So whether you're working with Particle or you're building your own solution, there are recurring costs for network connectivity, right? So if you're using a protocol like cellular, or you're taking advantage of a publicly managed, LoRa infrastructure, or a proprietary solution like Sigfox, there are ongoing costs to keeping your device connected and online. Device hosting. So even if you're building a product on Wi-Fi, generally when you deploy that product at scale, there's going to be recurring costs associated with making that piece of hardware available to the broader internet. And then also a lot of most IoT solutions don't just stop at getting data online, right? You're actually trying to do something with that data, extract value from it, and unless that's the core competency that you're developing as a business, the data platform is also oftentimes an ongoing cost that has to be amortized out through the lifetime of the product. And so this graph is meant to represent costs of deploying an IoT product. So you start, that center line is basically break even. And you think about it, well, okay, on a per unit basis, I'm going to amortize some R&D. I'm investing money and capital into R&D, and then I have to go procure my raw materials. That's my bill of materials, my cost of goods sold. Also includes things like production and transport, and we're going to talk about some of those costs later. But then, okay, great. But then you get this big bump. You sell your product, but then you have to support it. So what's left over as your initial hardware margin is hopefully above zero, right? If you're selling your hardware at a loss, then you better be creating recurring value downstream, and that's exactly what this is intended to illustrate, is that after the point of sale, typically those ongoing costs are going to eat into the margin profile of your product. So our number one recommendation for people trying to build businesses around IoT is figure out how your product is going to create recurring, continuous value on an ongoing basis. Because if it doesn't, then again, it's going to be really hard to monetize that connected product. And in a best case scenario, you can actually be generating more and more value for your customers such that your margin profile gets actually better over time, right? Or that you can sell hardware at a zero margin, on a zero margin basis, and then make your profit on the service side after it's shipped. So generally, there are tons of different ways you can monetize an IoT product, but we see them falling into these different buckets: consumer upsell and premium services, right? So how can you get someone to buy a more expensive thing or an attached service with connectivity? Reducing the overhead of staying compliant. This is actually about reducing the operational costs associated, right? So you can either create new value for a customer, or you can reduce internal costs to your own organization, and that can provide value on a recurring basis. Preventing catastrophic events, right? Flooding. It's sort of like their insurance business model, right? Hopefully it doesn't happen, but if you can prevent it from happening, that's great, because when it does, there's a huge cost associated with those events. Tracking high-value assets, knowing where your expensive things are so they don't get lost or stolen. Maintaining and managing the environment, right? So understanding more about the world around your product so that you could say, service that product more effectively. And automatic fulfillment of consumables. This is another really, really big one, where you can use the information gained by your IoT device to provide a value-added service and sell something to your customer at the right time when they need it most, because you have that information. So again, it starts with this business model. We're going to fly through this, but I cannot stress this one enough. So many people get to the point where they're deploying a product, and then they do the math, and they find out, my entire product's upside down because I haven't figured out how to create this recurring, continuous value. Build a prototype. And this is where, Particle, our roots are really deep here. We want to make this as easy as possible. Your connectivity solution should be based around constraints. So I see a lot of people who look at new connectivity technologies and say, I'm going to build something with that. And that's sort of the backwards way of thinking about it. You should say, what problem do you want to solve? What's your business model going to be? And then depending on the constraints of the product, does it need to be battery powered? How often does it need to connect and transmit information? What's the associated cost that your business model can bear? That's how you should be picking your connectivity solutions. And the reality is, like we covered earlier, there are a dozen different ways you could connect an internet-connected device, and it really comes down to what are the constraints of your product. That's how you should be thinking about connectivity. And then the second piece of advice I would add is begin with the end in mind, right? So when you start building your prototype, make sure you understand how you're intending to scale your product to mass production. Prototype, you want it to be fast, quick, effective, and illustrative of what the end consumer experience will be. But at the same time, if you have to start over, throw everything away and start from scratch because the part that you picked that you really love actually isn't produced anymore, or the cost profile means that your bill of materials are never going to get down low enough to make that product possible. Again, start your prototyping process. Try as best you can to make intelligent choices of the tools that you'll prototype with, such that those tools can scale with you as you build your product and refine it. This one's important because it's actually not about your product, it's actually about yourself or your team. Identifying the competencies that you can bring to bear to deliver an IoT product or solution. I think this is the most common one, and if all of you are getting into IoT in different ways, maybe you've experienced this within your own organizations as you learn more about what it takes to actually deliver on an IoT product. But most people look at IoT and they say, oh yeah, we'll just add a radio chip, make a mobile app. boom, IoT product, right? No, actually. There's a lot of complicated stuff that goes into it that requires such a diverse set of skills. And unless you are Google, unless you are Samsung, it's really unlikely that internal to your organization you have experience delivering on every single piece of that stack. So don't try to, unless you're planning to grow the next Google or the next Samsung, right? And so what I would encourage is to say, okay, reflect on the skills that you have. Reflect on the skills that are already within your organization, and then figure out what you can do, and then figure out where you want partners to help you learn and grow, right? That doesn't mean you outsource it. That doesn't mean you don't take ownership or stake or have a stake in what's delivered as, as a part of your product. But it means that if your business is dependent on you being able to deliver in a technical area where you have zero experience as a company, maybe you don't try to do that, and maybe you don't try to take on all of those challenges at once, right? IoT is unique in that it's such a deep stack that goes down to, to technical, very low-level silicon and hardware, as well as all the way up through, security, infrastructure management, and full stack cloud computing. So figure out where you think you and your organization are most effective in delivering, and try to figure out how to patch together the service providers or the partners that can help you deliver on the rest of that experience. And a quick plug, just because of course this is Spectra, is that we see so many companies struggling with this that we built an entire piece of our organization just to help customers identify their competencies and find the right connections to help work around where there are gaps in their skill sets. So Particle Studios can help with simple architecture reviews and make recommendations, or do full turnkey production services if your company has never touched a piece of hardware in their life, right? For designing for scale, the point here is that the things that matter in prototyping are very oftentimes different from the things that matter at mass production. So in prototyping, being able to, as quickly as possible, arrive at a proof of concept so you can demonstrate that value that this new product or this new initiative is creating to your organization. Really important. Accessibility of hardware, really important. Sample code and examples, such that you can quickly iterate, you can build on top of the use cases that have already been demonstrated in the market, that you can take libraries, take open source hardware, take code that others have created, and leverage that to your advantage so that you can demonstrate, again, and prove out the value of your proof of concept. And ease of use. Of course, IoT is a really new arena for most companies who are building their first IoT initiatives. And so having tools that are easy to use makes a big difference, right? It's the difference between getting your proof of concept to a point where you can talk about it, show it, touch, feel, and iterate on it, versus getting really stuck in the technical details where, when you're just trying to demonstrate a proof of concept, some of those low-level details aren't as important as the overall product strategy. So again, prototyping, things that are accessible, that can move quickly, fast. And then in production, obviously, a lot of it comes back to the business model, right? What bill of materials costs do you have to hit in order for your business model to be right side up? And then through that, okay, how do you plan through production volumes, right? At what particular MOQs are your suppliers giving you, such that you can order and produce, scale up your business, and again, continue to grow on the market and the traction that you've received in the pilot and early stages of your product deployment. Assembly at scale, this is another big one. We're going to talk more about manufacturing, but figuring out how you actually get your thing made can be a lot more complicated. If it takes you an hour to build your prototype, 10,000 units times 1 hour is 10,000 hours. That's a lot of time. So figuring out how your low volume processes are going to scale into higher volume processes are important, and that impacts not just your company operationally, but also the technology that you choose to implement into your product. Certifications and application notes, again, building on top of the problems that other industry partners may be able to help solve for you. And we'll talk more about certifications in a bit as well. And the last is environmental durability, right? Where is your product going to be deployed? Having something that works reliably on your desk in your office is a lot a lot simpler than having something that works reliably in the field for 2 years, when there's, near the ocean where there's salt in the air that's going to oxidize all your connectors, and or in a metal box in someone's apartment where it gets really poor RF reception. So again, thinking about the durability of that solution at scale versus what matters in prototyping. These are some of the considerations that go into, again, when we think as Particle about prototyping versus mass production hardware, right? So a lot of our prototyping hardware is built for that rapid assembly, ease of use. It's breadboardable. It's removable. The SIM card right on the Electron is removable, so you can, so you can try different service providers. You can figure out if you're having issues. You can swap and repair components. And then on the E-Series, it's optimized for a totally different thing. Exact same system, totally different use case. Machined assembly at scale, robustness to vibration and environmental factors. And it's packaged right in different volumes as well. So again, think about your own assembly process. Think about the tools that you can leverage in prototyping to move quickly to demonstrate proof of concept. And then, don't forget about the transition that every product needs to go through, which is figuring out how to maintain that same system, that same concept, but to assemble it using tools and processes that scale with your product as well. And this is one just tip that I've learned over the last 5 or 6 years working with particles. Whenever possible, co-design with your contract manufacturer. What I mean by that is, don't iterate in a corner, go through 20 versions, and then show up at your contract manufacturer and say, this is exactly right. Because they might take a look at your product and say, like, ooh, well, there's a bunch of things in here that are going to be really hard for us to deliver on, and that's fine, but you're going to have to produce and pay for 20% extra of them because your yield is going to be really low. And actually, we don't have the capabilities to do this kind of assembly process. We're going to have to outsource that. If you can iterate with your contract manufacturer, you can root out a lot of the issues that will happen when you transition to production during the prototyping stages. So rather than doing that in the black box, try to identify your contract manufacturer early in the process. Help them learn about how best to build your product, and the results will serve you as you continue to move that closer and closer to scale and mass production. Last thing is about certifications. Last bit that I'm going to speak about is certifications, and this sort of parallels to designing for scale is thinking about what the certification burden is going to be after you've finished producing your product. And I will be the first to tell you that I've spent a lot of hours studying the certification space. I've taken most of the particle products through certifications myself with the help of folks on our team, and it is really confusing. These are 5 different classes of certifications that that any one of them, or multiple of them, or all of them may be applicable to your product, right? Wireless certifications like FCC and CE are most familiar, but then there are regional variants of like FCC and CE that may be applicable depending on what region of the world you're operating in. If you have a cellular product, there are both broad cellular level certifications like PTCRB and GCF, which may apply to your product, and then if it's with a particular carrier, say AT&T or Verizon, there's an additional certification process for those carriers. And then on top of that, there are other certifications and requirements that might apply around ROHS, which stands for Restriction of Hazardous Substances, which is about the materials that go into your product, making sure they don't contain lead, for example. And UL, which is also a safety certification that most frequently governs devices and products that that leverage higher voltages, things that plug into your 110 volt or 220 volt outlets, right? Depending on how you build your product, these certifications might be relatively simple or really deep and intense. Generally, the guidance is that the lower level you design, like the closer to the radio chipset that you integrate, the more work you have to do as a product integrator on the certification side. Certifications are really sort of built in layers, right? So chipsets at the bottom are the things that actually support RF communications. Those are oftentimes packaged into modules for product integrators that they can buy and put on top of their board and interact with more easily. On top of that, you have products like the mesh SOMs that we just announced this morning that take groups of modules, microcontrollers, radios, compute, connectivity, package them together and certify that system. You as product integrators can take that system, put it into your own product. the higher up and the more abstracted the hardware that you integrate, most likely the less these certifications will apply to you. And the trade-off is between complexity and cost. So again, this is a world that a lot of times people don't think about or build into their schedule, but that can take 3, 6, 12 months even, especially on the cellular side where things are the most complicated, to get right. So again, I encourage you, if you have questions, definitely ask them. But in general, these are worlds that a lot of your hardware partners and your software partners may be familiar with and can support you through this process to ensure that your device is fully compliant and won't be delayed in getting to market. So that wraps it up for the first half, sort of the prototype and prep for scale piece. I'm going to ask Margaret to come back up to walk through manufacturing all the way through to fulfillment and support. And then we'll have time for some questions at the end as well.
Great, thank you. Oh, can I grab that clicker?
Yes.
Thank you. Okay, so now we're going to assume that your prototype is done and you feel pretty good about it, and we're going to go into manufacturing. So I want to throw it back to what Will said earlier, where he said, oh yeah, I just put a chip in there. On the production side, you have something similar. It seems really easy. You made a sample, it kind of works, it looks good. Besides, you have partners, and they're going to help you with this whole process. Well, it turns out it gets a little more complicated than that in reality. The path between 5 and 100,000 is tough. And I want to share with you all a couple stories of things that we've run into along the way. And I will tell you these so that you won't have these, but they're pretty obscure, because a lot of what happens when you're producing 100,000 units is that obscure things happen to you. And so that's why when you design this entire supply chain system, you need to design it with partners in mind and to be flexible. So here's a good example. Here's a part Will helped me source, and it had a lovely lead time of 8 weeks. So 8 weeks is an okay lead time. It's not the best. You'd want it to be immediate. But all of a sudden, it turned into 26 weeks overnight. So you can imagine what happens to your supply chain when you were used to getting parts in 8 weeks, and now you can't get them for half a year. So that's one example you can run into when you expand. Here's another example. So this is like one of my least favorite parts of the particle products, this breadboard. So you may notice this breadboard is a lovely shade of white, which is difficult to source. But in addition, we did a lot of quality control around the beautiful white color. What we didn't realize is we also need to do quality control around how tight it is. So a breadboard is not as helpful when you can't get your components in there. So that was another thing we ran into when you get larger and larger sizes of your product. Is this off? No, okay. All right, let's do another one. So launch. So we're also gonna go in, oh God, I keep skipping ahead here. We're gonna go into the launch section also and how you're gonna get these out to customers. Another example of a thing you run into when you have 100,000 customers all putting their information in and you're trying to ship products to them is things you've never thought of before. So I'm sure when you do testing of your e-commerce platform, you probably don't think to put in Korean characters. Well, turns out they all got rejected. So we couldn't ship to anywhere in Korea for a little bit because of the Korean characters. My final story is a story you all might have been following in the news, is that tariffs don't necessarily stay the same forever. And we found that out lately. So this is another example of a trip up you can have if you design your supply chain inflexibly. You can get tripped up by just the way governments are working together these days. So to get us back to this process, we're going to go through and we're going to start with manufacturing. And one of the things Will talked about a little bit is your contract manufacturer and how important that partner is to you. So I'll talk a little bit about some myths of contract manufacturers. We've done various contract manufacturing sourcing, and I think it's interesting that a lot of people still have these misconceptions. So the first thing is that if you get a great contract manufacturer, everything's going to go great, and they're going to manage all these problems for you. Actually, the idea of production management is a full career, and there's people who are very smart people dedicating their lives to this, and it's making sure that things go smoothly and monitoring issues as they come up is a big deal, and having someone internal to your company doing that is critical. Other ones are picking the CM with the lowest price. I've found that about 30% of the cost is not the cost you're getting quoted from the CM. It comes when you're doing rework. It comes when you talk about how their import-export licenses are structured. It comes from a lot of different other factors. So picking the lowest cost is not going to give you a total cost of ownership here. Another one is larger CMs are cheaper. Not true. It's very interesting. And my favorite one is they had a beautiful presentation. I'm going to go with them. I did have a slide in here that was just the horrific clip art that I've gotten in CM presentations, but I took it out because I thought it was too mean. And then lastly, I'll pick the most technically strong CM. So this is actually interesting. It gets back to our point of we need to think about the product. You might not need a super technically strong CM, and but you might. In a lot of cases, if you're doing something simple, you actually don't need the CM to have complex testing equipment, and maybe you'd be paying more for a CM that does. So with that in mind, I think about three things when you're choosing your contract manufacturer. So one, you want to think about the capabilities that they need. Are you doing finished goods and you need them to do assembly, or are you just doing SMT, like basic PCBs? You also want to think about customer service and management. So how flexible are they going to be with you? Do they speak English? Do they have a dedicated rep for you? All that sort of thing. It makes a big difference. And then finally, the volume. Volume is not volume is not volume. So if you ask my CMs what is their least favorite product at Particle, they would say the sensor kit, which is a incredibly large collection of random sensors, and very helpful if you're going to do some prototyping, but not helpful to a CM that's trying to make a good margin and doesn't get very much on final assembly. Cool. Another thing that a lot of people are thinking about now is where are you going to locate this manufacturing? So traditionally, the choice was between the U.S. and China, and the trade-off you're looking at there is really a cost versus ease and flexibility question. So you want to think about what kind of volumes you're doing, what kind of iteration you're going to be doing on those, and think about that. Of course, customs risk is a big deal now, especially since we're seeing that a lot of the components and a lot of the finished goods involved in electronics manufacturing are going to have a 25% tariff on them starting in January. So yeah, you can think about that trade-off between the U.S. and China. U.S. you're going to be paying, say 2 to 4x more on labor costs, but you might be saving on parts at this point in time with the tariff structure. There are also a lot of really interesting mixed solutions you can think about where you do initial SMT in some locations and you do final assembly in another location. So that can be a way to work with the tariff situation or also get the best of both worlds. Cool. Okay, so you picked your contract manufacturer. You're ready to go. Let's talk a little bit about testing, because this is another section of the process that I think gets overlooked a lot of the time. And the creation of your testing infrastructure can be equally as complicated as the creation of your prototype. There's really 3 types of testing. There's functional testing, there's automated testing, and there's ad hoc production testing. So when we run through each of these, there is an art to determining what tests go in which piece, and there's an art to setting this all up beforehand so that you're actually getting results out of your testing. When you talk about functional testing, this is the testing that you want to do before you start your pilot runs and after you do your pilot run, so that you can make sure that what you have is totally stress tested for a lot of different use cases. So like end to end, does it actually connect to the cloud? Can the customer log in? Things like that. And you also want to do a bunch of, like if you have sensors, for example, that's a common place where you might want to do a bunch of testing around calibration, things like that. Then automated testing, this is your test rig. So this is the thing that looks like I like to call it a waffle maker. It basically has an arm and you put your device in there. This kind of testing is what you need to do for every single device. So what you need to make sure for every single device is what could go wrong with every single device. So things that could go wrong at any one time are the parts aren't getting connected. The two parts talk to each other funkily in this one time. The solder didn't get fully put on. The firmware flash was corrupted in some way. So you want to check those for every time. And the development, don't underestimate the development of this step. It's going to take you a fair amount of time, especially if you haven't done this sort of test before, to make sure that you test the actual capabilities of your device. And then lastly, you want to pull out some units after you produce. So, classic sampling, cosmetic inspection, and end-to-end testing on a batches of units. And then, of course, you do a trial run. So the most important thing about the trial run is you want production everything. You want production parts. So I can tell a story about a part that we sourced for the samples, and then we sourced a new supplier for the final goods, and it didn't function exactly the same. That's really common. You want production process. You want to make sure all your people on the line are doing the right thing. You want production firmware, and you want production test process, because all these things can introduce error. So in your final step, you want to make sure you're doing final everything. All right, cool. So now we're ready to ship. So we've got different kinds of shipping too. You've got inbound material shipping, bulk logistics, and outbound logistics. These are my own terms. There are some better industry terms out there, but I like to think of it this way. So material logistics, this is going to be dictated by agreements with your suppliers. So you're going to be on their lead times. And so a lot of what you think about with material logistics is planning ahead and making sure you're going to get your stuff in at the right time. So importation is never fun, big problem on that side. And I've had a lot of runs delayed because you just don't know when your package is going to get inspected by border control or whatever. Bulk logistics, you have the air versus sea question, but there's also a lot to think about on how you consolidate and where you're sending it. And finally, you've got outbound logistics. There, you're worried about cost versus service level to your customers. So maybe your customers are expecting prime level. Prime has ruined things for a lot of us. They're expecting prime level speed to get to them at prime level cost. In that case, you can work on your contracts with shippers, that sort of thing. Cool. And then you've got to choose a third-party logistics partner, most likely. And this looks a lot like choosing a CM. You want to just think about your product, what capabilities you actually need, what you actually want them to do for you. Try not to, you really don't need to get any more than you need here. Because if you get somebody very sophisticated who does a lot of hands-on stuff and you're just shipping out to Amazon every day, you're going to be overpaying. And then you need to think about how your volume is going out. Great. And then, of course, this is the scary slide. Will had one, so I needed one too. Which is that there's a lot of red tape associated with customs, shipping, logistics, and just be careful of all this stuff because it can bite you. of course, tariffs is like the big thing that can bite all of us right now. But there's also things like there's been a huge increase on lithium battery regulations recently that have been confusing to follow and have really changed how we have structured our supply chain. So I would say ask your shippers and your 3PL for advice on this stuff. They are really the experts. Okay, so retail and distribution. So now we're going to sell the goods. And here, there's a lot. This is an area that will really vary for each one of you, depending on what type of product you have. A lot of times, you'll have an existing direct relationship, or you'll have existing reseller or distributor relationships. So I won't go into it a lot because this is pretty unique to every product. But what I will talk about a little bit is the trade-offs between selling directly and selling through resellers. So this is something we've thought a lot about at Particle, and we do have a lot of resellers who are really beneficial to us and good partners for us. But it does come with some trade-offs. So if you're going to sell directly, the benefits to that is that you control the pricing, you control the message, and you control the customer data. I didn't put that one on here, but that's big. So that's your email list you just got. And you also keep the full margin. The problem, of course, is you're managing all the fulfillment and you're finding those customers. So if your marketing is weaker, you're out of luck. You don't have an existing customer base beyond the whatever you came into this product with. Selling through reseller is obviously the opposite. So you're gonna sacrifice some of the control you have over that product, and trust me, like it can get. You can definitely suggest messaging and how you think your product needs to be placed to resellers, but they have an existing product line that they're trying to fit you into, so you're not always going to get your way there. And then, of course, you're going to give up margin. So that's a thing to think about relative to Will's business model thing is you need to make sure that when you are doing this, if you do have resellers down the line, that margin is incorporated in your business model. But what's great is if you do sell on Amazon, you get to take advantage of Amazon Prime instead of being hurt by it. And then you also can leverage their customer base. This is really the most valuable part. It's that you now can tap into this customer base you could never have found on your own. Of course, you might not get their emails. So, all right, cool. And we're almost at the end here. Fulfillment and support. So what happens now you sent it out? What happens next? So don't think that the job is done, because unfortunately, there's also a bunch of things that happen after you've shipped it out. So one is return logistics. So you've got to get those products back if people are returning it to you. And that can be tricky. In some cases, it might not justify it. So if your product is only $30, shipping it back from Russia is not going to make sense because the shipping back might cost you $15. So you need to think about some of those rules there. You're also going to have to set up some customer troubleshooting and think about. In this one, my advice is that the more you can get your troubleshooting to be one-to-many, as in you post it, you make documentation, and that helps many customers, the better, versus having it be one-to-one in an individual customer support system. And then finally, there's ongoing support on all products. So, Particle is a good example. A lot of our products are incorporated into products that then are going to be on the market for 5-10 years. So we function similar to most suppliers in that we publish end-of-life timelines, and we have to we notify customers when products are getting towards end of life, so that they can then use those to reflect back to their customer base. So think about that as well. So to come back to the final, I'll bring Will back here. To come back to the final themes here, start with your problem, not the product itself. Make sure you're not underestimating the time costs and complexity, and then make sure you find partners to fill the gaps in your own capabilities. Thank you.
Thank you. Any questions?
Yeah, we're sort of evaluating like Particle Studios as a potential partner for developing our hardware and trying to also understand what burden we'll have to take on ourselves. So if we are using Particle, where do you guys sort of step in and help? What are you guys really good at? If it's like certification or manufacturing, what areas should we be conscious of that we probably take the burden on ourselves to go find?
Yeah, that's a good question. So the question was basically, if I'm building a product, I'm thinking about talking to a group like Particle Studios to figure out, okay, what can you help with? Where do you expect that I'm maybe building competencies and investing, our own time in the business? So here's what I would say: we have done a very, very broad spectrum of things. We've done things as simple as spending 10 hours with a customer to sit down, review the existing design files, and make recommendations, right? And we've gone as far as doing full turnkey, which is you define the requirements, and we're going to show back up in 6 months with a fully scaled production assembly, a product that's fully certified, robust firmware and hardware that's gone through multiple iterations. So it really can vary. I think generally where on the certification side specifically, if you're using particle hardware, generally that comes with the hardware, right? So most of the products that we sell, especially the ones that we sell at scale for enterprise deployments, those are oftentimes going to be pre-certified, or the burden of certification is going to be a lot lower, right? I think we think of that as a business problem that we can effectively solve if we create thoughtful designs and go through the work to unblock that up front. So I think where every single product is unique in a couple different areas. One's in the hardware, right? But every IoT solution also, especially on the cloud side, there's a really, really broad variety of ways that once data is up in the cloud, in the internet, that you can make use of that data. And that's, I think, where typically we need to work together. That's not something we can always do turnkey, because you as a company maybe have your own database solution, or you have your own customer management platform that you use. And that's sort of where we need to plug into the existing systems that you already bring to bear and that you define as important to you and your team. So I would say, if there's an area where, collaborative work is most important, it's in the how does this product and this information integrate into the rest of your business? Because that's not something we can do for you necessarily, but pretty much everything else, further down the stack into the connectivity and the certifications and the hardware, and again, even the production, those are all things that if those aren't competencies or places where you want to invest time because they're not critical to your business and you'd rather work with partners, we can absolutely support on pretty much everything.
Another question? Yep. We haven't sourced or manufactured in those locations yet, but it definitely feels like a lot of S&T style manufacturing is moving out of China right now. We have seen a lot of contract manufacturers with locations in Vietnam and some other Southeast Asia areas. And if you look at the overall manufacturing landscape, really the canary in the coal mine for manufacturing is the textile industry. That is an industry that has light machinery, high labor, and usually that's an indicator of a broader staircase to more advanced manufacturing. And really what you've seen is the textile industry was big in China in like the 80s and 90s, then mostly moved to Southeast Asia. So I expect that we'll see a lot of that happening with electronics too. That's sort of the next step. But we don't have experience in the Philippines specifically.
And one just quick thing to add on to that is a lot of it really does scale with the cost of labor, right? And I think it's easy if you or your company has never manufactured a physical product, it's really easy to think about a manufacturing environment as like, a machine arm grabbing one thing and handing it up to another machine and this like totally automated process, but that is not the case. Humans are very much central to the manufacturing process in most assembly environments, except for maybe like automotive, where that's the one case where you really do see the assembly line with the the robots taking care of a lot of that work. So a lot of it is really associated with the cost of labor, and that is absolutely something in China that's increased. I mean, even in the last 5 years, it's close to doubled and is likely to continue rising. And so thinking about whether your product has higher technical requirements of assembly or is a more manual assembly process will also help dictate where you choose to invest in building up your capabilities.
Another thing we've seen is companies that are moving their primary manufacturing into more inland China, and then they'll have what's called a test line in the primary centers, so Shenzhen or another like bigger coastal area, and so you can do pilot runs on those lines, and then you can do your primary manufacturing in another location. That's a trend we've started to see.
I think unfortunately we only have time for one more question. I can at least speak for myself. I'll be hanging around afterwards. Margaret,
Yep.
I'm sure will be too. So we'll take one more question and then come find us afterwards if you have more. Sure, in the back.
That's a really great question. So we, from a manufacturing standpoint, and then you can probably answer more from the design standpoint. One thing that's more impactful than the volume is the total value of the goods. So if you're manufacturing 1,000 units, but those units are high value, it could look different from the contract manufacturer standpoint than if you're manufacturing 1,000 at a low price point. So that's one thing to keep in mind. I would say there is some sort of psychological breakpoint around 1,000, I've noticed, and then probably another around 20 or so. Those are some things I've noticed, but it really varies based on the cost of the individual product.
Yeah, that's been my experience as well. Thinking about the value of your product is really the right way to do it. Oftentimes, contract manufacturers will charge and make money based on a percentage of the value of the materials that they're handling, right? So if it's 1,000 units, but they're $100,000 worth of goods each, right? That's a much more approachable situation, but requires a different set of skills. So that's going to put you into a low volume, high touch, high skill set kind of environment. Whereas 100,000 units where the bill of materials is $1 and it's basically a printed piece of plastic, that's going to be a totally different scenario. And as far as thinking about tiers of contract manufacturers and the really big ones like Foxconn and frankly I'm not exactly sure, right? We are not at that volume, certainly. Apple is at that volume. But really, I think for some of the larger folks where you'd consider basically like, okay, do I go with a smaller sort of mom and pop style, like really white glove, good service, big fish in a small pond kind of environment versus when do I graduate into being sort of having meaningful value to a larger scale contract manufacturer? Generally around $1 million annually of product per year. So you can think of that as 100,000 units at $10 a pop in terms of your bill of materials. That's a transition point where contract manufacturers will become more interested, and you'll be a more representative customer and more representative demand. But I mean, we've had such great experience with smaller CMs as we've launched new product lines because the flexibility that is afforded to you when your product is new is really valuable. So don't necessarily walk into the biggest CM you can find and say, hey, we're going to be doing 1 million units by this time next year. Appreciate the treatment that you can get in smaller facilities because it can be really helpful when you're still ironing out the bugs in the product. Great. Okay. Well, I think that's it. We'll be around afterwards, but thank you so much for coming. Enjoy the rest of the conference.